In this video, I will be introducing the numerical approach to finding limits. So to numerically analyze a limit, we must take the left and right-hand limits approaching x, and when we take the left-hand side limit, we write it as x approaches c with a negative superscript, and when we write when we want to demonstrate the right-hand limit, we write it as x is approaching c with a plus as a superscript. So to analyze the limit, we make two different tables. So say we were investigating the limit of x squared as x approaches 4. To analyze it, we would make a table of values for f of x for x close to but less than c for the left bound, and then for the other table you would make you would do x values that are close to but just more than c. So the left bound table would be 3.9, 3.99, 3.999, and so on and so forth until you get closer and closer to 4. And this would be 4.1, 4.01, 4.001, and so on and so forth as you get closer to 4. So by plugging these numbers in, we get these numbers, which I've just calculated beforehand. You can do it on your calculator if you would like. So as you can see, on the left side, we are starting at 15.2 when we're gradually making ourselves closer and closer to 16, and that is the same on this side where we start on 16 with 16.81 and we're making our way closer and closer to 16. So if both tables, like in this instant, indicate convergence to the same number, which in this case is 16, then that number can be assumed to be an estimate of the limit. So we can say that the limit of x squared as x approaches 4 equals 16, because you can see that this happens in the graph, so we can graph it and see, we can estimate it like that, and we can also do it through table of values. So there is also going to be instances if no pattern emerges, which we will work with later on in the video. And this occurs if x values jump all over the y values jump all over the place. Then the limit may not exist, or there may be discontinuity. So you could have one side going up into infinity and one side having 1 point, or both sides going up to infinity. The function itself as a whole will not be continuous. So but also when we are doing numerical approaches to finding limits, this investigation only provides evidence for a limit, but it doesn't actually guarantee that the limit exists or has a given value, because if, say, on this graph there was a hole here, doing this through the numerical approach would still give us 16, but it wouldn't give us the fact that there might be a hole here. So we just have to keep in mind that numerical investigations only suggest that the limit exists, but it can't be proven. Only limit laws can do this, and that will be discussed later on. So now that we know how to, the basics of the numerical approach to finding limits, we can do some practice questions. So the first question is, what does the following table suggest about the limit of f of x as x is approaching from the right side to 1, and the limit of f of x as x is approaching from the left side? Oh, sorry, left and then right. So overall, there is no clear pattern to where the function is going, because the left side does not converge to the same point as the right side will be going. And this means there is no overarching limit for f of x. However, since it's asking for the limit of f of x from left and from right, we can break it up. So the limit of f of x from the left side, we can see that the numbers are growing by like a big difference every single time. So we can assume that from the right side, as the limit approaches 1, it is going to positive infinity. So it would have an asymptote at 1, and then it would be going to positive infinity. So this is x equals 1. And then from the right side, the numbers start at 3.0126, and they keep going down all the way down, but it doesn't seem like it's going to go under 3, so we can safely assume that from the right side, the function will be going to 3. So say there's 3 here, the function will be going to 3, well, whatever the function is to begin with. So the limit of f of x as x approaches 1 from the positive side equals 3. And we can tell this by the information that the table is giving us. A second example for questions that we can get with the numerical approach to finding a limit is actually plugging in the numbers to find the limit. So here the question asks, what is the limit of f of x as x is approaching 1 when f of x is x cubed minus 1 all over x squared minus 1. So from the beginning of the video, we know the first thing we have to do is set up two tables, with the first table being the limit of f of x as x is approaching 1 from the left side. And then your y values will be x cubed minus 1 over x squared minus 1. So we want values that are less than 1 and getting closer and closer to 1. So let's start with 0.998, 0.999, 0.9995, and finally 0.9999. And then for the second part, we can do it from the right side, so the limit of f of x as x is approaching 1 from the right side, and then our y values will be x cubed minus 1 over x squared minus 1. So you can take the time now to calculate the values. So we're going to do 1.002, 1.001, 1.0005, just getting all the way closer to 1 and never actually reaching 1. We want to see if these two tables will converge to the same number. So you can take the time now to calculate both the left hand and the right hand side, and then I'll just plug in the numbers. So here are the numbers for the left hand side, and here are the numbers for the right hand side. As you can see, both tables seem to converge to 1.5. which means that the limit could exist and that limit could be 1.5. Remember that we can't actually prove that this will be the actual limit of it because we have not applied the limit laws yet, but from this numerical approach, we can assume that this is the limit of f of x as x is approaching 1. So the limit of f of x as x is approaching 1 equals 1.5.